The diagram shows a train of an engine 90 tons pulling two trucks, each of mass 20 tons. The engine exerts a driving force of d newtons and experiences a resistance to motion of 2,250 newtons. Each truck experiences a resistance of 640 newtons. The train travels on a level track with an acceleration of 0.25 meters per second squared. A. Calculate the value of d. B. Find the difference of the tension between the engine with truck A and the tension between the truck A with truck B. Okay, so basically we've got to find the driving force here, the tension here on this tension coupling, the tension here, and then work out the difference of the two. Okay, so in all mechanics question, you need to draw a diagram. So what we're going to do is treat this all as one object. We'll just treat it as a rectangular block. Okay, so the mass of that block will be 90 tons, which is 90 kilograms, plus 20 tons, which is 20 kilograms, and another 20 kilograms, which is 130,000 kilograms. We have a driving force D, and then the resistance will be 2,250 plus 640 plus 640, which is 3,530 newtons. And we have an acceleration of 0.25 meters per second. So treating it as one object will allow us to find the value of d quite easily. So, just putting that information in again, just drawing that diagram, so just putting in the actual figures here. So we've got a mass of 130,000, resistance 3,530 d. So if we now resolve this horizontally, we're going to get d minus 3,530 is equal to the mass, which is 130,000 times the acceleration using Newton's second law. And therefore d will be 130,000 times 0.25 plus 3,530, which will give me 36,030 newtons. Right, if we now look at the whole system, so we have an acceleration of 0.25 meters per second. We have the driving force of 36,030 newtons. We have a resistance here of 2,250. We have a tension in the coupling T1 going that way, and then for the truck A, the tension will go that way. Truck A also has a resistance of 640 and a tension T2 pulling that way. Truck B will have a tension T2 pulling the opposite direction and a resistance to motion of 640 newtons. Okay, right, so now considering each of these individually, so we'll consider first of all the engine. The engine is 90,000 kilograms. It's got a driving force of 36,030 newtons, a resistance to motion 2,250, and T1, which I need to find, and the acceleration is 0.25 meters per second squared. So, resolving horizontally, we're going to have 36,030 newtons minus 2,250 minus T1 is equal to mass times acceleration, so it's 90,000 times 0.25. And then rearranging that, we're going to get that T1 is going to be 36,030 minus 2,250 minus 90,000 times 0.25. Working that out on my calculator is going to give me 11,280 newtons. Right, we'll now consider truck B. The reason for doing truck B is that it only has one tension in it. Okay, so we've got T2. We already have T1 already. So we've got T2, we've got resistance motion of 640 newtons and the same acceleration, 0.25 meters per second squared, but its mass is 20,000 kilograms. So, resolving horizontally, we're going to have T2 minus 640 is equal to the mass, which is 20,000, times the acceleration, 0.25. Therefore, T2 will be 20,000 times 0.25 plus 640. And work that out on my calculator, you're going to get 5,640 newtons. Right, we were asked to find the difference between these two. So the difference is 11,280 280 minus 5,640, which also gives me 5,640 newtons. Right, we can just check this calculation by looking at truck A. You wouldn't have to perhaps do it in an exam, but it might be a good idea to do. So if we can check with truck A, so truck A is 20,000 kilograms. We've got T1 in that direction, T2 in this direction, a resistance to motion of 640 newtons, and an acceleration of 0.25 meters per second squared. So if we now resolve this horizontally, we're going to have T1 minus T2 is minus 640 is equal to the mass, which is 20,000, times acceleration, which is 0.25, and therefore we're going to have T1 minus T2 is going to be 20,000 times 0.25 plus 640, which gives me 5,640 newtons. This is the actual difference, which is the same as before, so we were okay. So this has been a video to show you how to find a driving force of a train and the difference between the coupling forces on each part of the train. I hope you've understood, and I thank you very much for watching.